Yeah, thanks for making time today. I cannot tell you how dazzled I was by what you posted. It was just um it was short and it flipping works.
Yeah, it works. You did. I don't think you believed me when I said it's just 5 minutes, right?
No, I didn't. Actually, so I guess I guess what I didn't fully, if I understand what you did is you just created the adjacency list,
Mhm.
and then just gave that to um
Okay.
Mondrian.
Mhm.
So, well, that's freaking easy, and that's just a list of uh, it's a list or ordered list of edges.
Mhm.
Is that all it is?
Yeah,
So that makes sense. Which is actually the same format as graph is. Is that right?
similar. It's not the
Yeah.
same, but yeah, the principle is the same. The graph is just a graph. You have
Right.
nodes, you have edges, and that's pretty much it. And a layout.
Could you walk me through it? I mean,
Yeah,
it's
let's do it again. I would say, let's do this one maybe in slow motion.
right.
Um,
And should
Either you
I?
do it.
Yeah, that is wild. And actually, I wrote down if you don't mind, maybe one of the things that we could do if we have time, uh,
Sure.
is I sort of wrote down some of my reflections on
Hmm.
last time. Just
Yeah.
the I guess one of the takeaways for me was that wow, all UI systems are complicated and idiosyncratic, just as a rule. And I was really dazzled by the fact that you can reach into Node.js and leverage all that. Um,
Hmm.
in fact, actually, maybe before we begin, could you show me how, in the example, where are you actually? In fact, here I'm going to share my screen. So if I understand correctly, this is a oh, is this the package.json example? No, this is like a database one.
Yeah, that's just you can see it on the left here how to
Yeah.
that package.
Oh yeah, here's the
Those are
package.json one, right?
and that's from the book.
Uh, yep. Oops. So where are you actually getting?
Open the document in Glamorous Toolkit.
Okay, let's do that.
So just what's the name of it? Something with no. What's the name of the document? You are looking at it.
But
Mm,
is that it?
yeah, yarn.lock. I think you have to look for yarn.
Oh, uh, oh, yarn.lock.
Yeah.
And is this actually the mechanism you're using? Is the a server to a Node.js?
Yeah. So this is an actual, it's a multi-language notebook.
Yep.
And not only are there, is that like, Pharo and text, but you can have all sorts of other languages. So here you see two
Got it. So
languages. So
um,
you get the snippets from the top, and
yep.
if you run those, and you can get the visualization eventually.
Okay, so it's creating a variable called lock file JSON string.
Yeah.
Wait a
And
minute.
then you
Yeah.
get.
So how is the binding made from here to here?
That's the magic. So
Right.
no, I mean, so you have you see here this log file content, right?
Yep.
It appears here. And then you have the log file string appears then here, right? So this is from Pharo to JavaScript, and this is from JavaScript to Pharo.
Oh my gosh. So, okay, that's surprising. So this thing is in the lexical scope of the notebook.
Of this notebook.
Okay. Okay, I got that. I'm actually really surprised that you can go from here to here. Okay, great. So basically, somehow you've created a lexical binding from Node.js from the notebook.
We have a proxy model.
Yeah.
That with which we can actually take bindings from one language, pass it to another, and talk with those and get results from something, put it somewhere else.
That's cool. So very much like we saw in the Squeak Truffle VM video that I posted.
That's different. There, the work is done by the VM, right? So that happens within the VM. Here, you're having inter-VM communication.
Right, but you're achieving the same thing
from an end user perspective, yes. But there, for example, they will be doing it. So this thing will be probably faster. The exchange, but it will scale only to the extent the VM scale. So those kind of things. We also have here, and again, like it's easier because the VM does that work. In the case of Truffle, no, what's the name of Truffle?
Truffle VM. Yeah, it's the Graal VM.
Right, and the Graal VM, yes. So in that case, the debugging, so how do you do debugging? So here we actually have, we have within the same debugger, we can also debug JavaScript.
How does that work? Wait, how do you reach into how do you reach into the internals of the Node.js process?
So you implement the debugger interface, right? So the Node.js exposes a debugging interface, and you connect to that one and you work with that one. This is how any debugger works. The key is, how do you make the debugger work with the same infrastructure? So, and in our case, we can have a debugger that starts in Pharo. So here, if you have some breakpoint in JavaScript, you can start in Pharo. And when you hit the JavaScript debugger, the debugger transforms itself into a JavaScript debugger. And then it goes back to,
that's amazing.
You can flip between back and forth. You can debug both of those at the same time.
I'm just going to bookmark this for myself. I was watching a talk about how the Joyent folks sort of created like a dtrace interface to Node.js for their production applications. That's really awesome. That's that's great, Tudor. Okay, cool. All right. And maybe just to kind of expose my wonderings, I'm still trying to formulate in my head, like, and I think this exercise will inform that. It's like, all right, for certain types of problems, where do I want to solve it? Do I want to be doing it in Clojure land? Do I want to do it in JavaScript land and use things like D3 and Vega and Vega Lite, or do I want to do them inside of GT? And so what we're talking about certainly opens up, options in terms of what you can do where. So just to expose kind of a wondering I'm having. Okie doke. All right, let's parse some Markdown.
Do you want to talk about that or not? Not now.
How about we do that after?
After, fine.
Yeah. And I was reading. I scanned the paper that you wrote on Mondrian a decade ago.
15 years ago.
15 years ago, right? Maybe just, and so that's kind of co-evolved with GraphViz, Vega, Vega Lite.
So what you see, the goal here with Mondrian was, and it was the first attempt to build something where you get this super fast feedback with scripting, and probably was one of the first. But there were tools at the time where you could visualize things, and you would give it data, and the tool would get the data in. It would take a while until it would massage the data, and then you would be able to apply visualizations on top of that one. But most of those visualizations were click, click, click things, kind of like how most UIs are today. So in here was, well, what if I don't have to transform all the data? What if I just need a few pieces of it and project everything else? And that was one of the very first experiments that I did, and it's also a long-lasting one.
Yeah.
Which said, well, actually, you can leverage. It can be less performant because you don't have caches and so, but because you're just focused on exactly what you're looking for, you're better off at the end.
Yeah.
And then at the same time we also focus on expressivity. So how do you express graphs really focused? So if you look at something like Vega Lite, or you have higher level, like you don't have really predicates. It's not always a language of predicates.
Right.
That you can combine easily. So that's the kind of thing that you see. So there are other things like if you have a traversal framework, which we do, which is really small, they're really small, but then you combine the traversal framework with the visualization, and then again, like with a very small compact way, you can boom, produce a visualization. So those are the kinds of pieces that people miss when they just look into let's get they evaluate the visualization by the UI, and that's most of the time not the most interesting thing.
Could you just say a little more about that? I mean, like yesterday I had shown the JavaScript front end to GraphViz, which I thought was marvelous. I discovered that only 2 weeks ago. I mean, so like, what is your feeling like when you see that, and like the Vega Lite editor, right? I mean,
so Vega Lite I think is really interesting. It's super exciting because it's what's interesting about it is that it's a declarative way to construct visualizations, which means that you can take it from here, port it there, and it's secure, for example, which is very interesting. If you take something like D3, then you're in an imperative world there.
Yeah.
So then you can start comparing there. Then of course they can have lots of things, but then the question is, how concise is it?
Yeah.
Is it super? And then how combinable is it with other pieces of information? So this is basically where so I kind of evaluate engines or under with two dimensions. So expressivity, so how many things can I express with this, and then conciseness, so how much of an effort or how compressed the effort is needed to achieve whatever I want to achieve. So these are like the two dimensions that I prefer to do. But then there's the third thing, which is composability. So like when you create that visualization in JavaScript, that's going to be, if you compare that one with just looking at the data table with text, you already got your benefits. But the visualization is that's where the conversation stops. In our case, right, any visualization, any new projection you make is the beginning of the next conversation. There's no endpoint. There's so many comparisons today, right, are just done at the very shallow level. Oh, this is what I see, that's what I want, boom, that's it, right? And then it's compared with the current status quo and not with the possibility. So that's so at this moment in time, I don't think there is anywhere any match to this the level of kind of composability that you can get. So with this, for example, with the Markdown 3 or so, you build the visualization, but that visualization was instantaneously browsable, and by combining it with the view of the ASD, you actually even got highlighting, right? So super simple, and it was there by default, right? You could just leverage what already existed. Now, and this kind of compounding it's hard to get, right? So
Right.
when you have something that has an exponential curve, you never compare, right? This is something we learned in the pandemic. Some countries don't, but like you should never compare absolute numbers. Compare
Yeah.
trajectories, and that's the kind of thing.
Got it. And let me just reflect back at you what I heard. So it might be easier to compare the Vega Light and the Graph Viz. That kind of lives on one thing because they're declarative, right? Where you probably view Mondrian as competitive is more in the D3 space. Where there's more overlap.
Yeah, but and there's this, so the way, like
and
every time
there's
you want to choose something, these two dimensions, keep them in mind, right?
Right. And
So-
there's this whole other horizon of like, what does it look like? What does the world look like when visualization is not just the output, but something much closer in within reach that you're actually integrating into your daily work?
Yeah, exactly.
Yeah.
So all of those things, they make sense, right?
Okay, cool.
So maybe
in fact, you
just
got me super excited to.
Okay, so we were on the topic of debugging JavaScript. So actually, let me show you. I can show you very quickly, and then we jump into the Markdown parser. So, so here I have, this is from the book. So I have here, I started, I said I wanted in a debug mode, the JavaScript link. So I can do CMD to see where it is. I can execute something like this, simple things. I can put a debugger here. So if I put a debugger here, what happens is, oops, I'm going to share the whole screen. What happens is that I got this debugger window, right? So this debugger window is actually JavaScript now. These are JavaScript, this is JavaScript code. But interesting enough, like I can flip back and forth between this is the JavaScript part, and this is the GT part, and you can see that it sends and waits now.
Yeah.
Which makes sense, right? So I was in Pharo, I was running it, now I'm waiting for it. And now I get a debugger here, and now I'm executing there. And I can continue, and I get the result here. And I can even do something like this. So in this case, we do some factorial. Again, there's a debugger in my code. I can continue, and there's a debugger somewhere else in the code.
So this is a JavaScript stack.
Yeah, this is a JavaScript stack.
And then below is actually, can you actually see? Oh, and then the flipping is the stack is the other
debugger,
Pharo
yeah.
Yeah.
So there's this wait for value kind of thing. And
cool.
And, and the interesting thing here is that we didn't do it. We didn't change the debugger. We just added one because the debugger is also moldable. So it can, by moldable means it can adapt to whatever the context is. Just like you have views for the inspector, we have views for stacks.
And is it the correct use of composition to say that now the debuggers compose? I mean, there's a debugger instead of a debugger. Yeah, that's crazy. I've never heard of such a thing. That's cool.
Yes.
That's cool.
So
all right,
let's go back to your Markdown.
All right. I'm looking for
the summer.
I'm sorry.
There's the song Looking for the Summer.
Summer?
Yeah, there's a song called Looking for the Summer.
Oh, let's see, GK page name. Okay, should I just create a new one? Can I duplicate this page?
You're not sharing the screen.
Oh, sorry. Got it. And let me share. Holy cow. Zoom now lets you share multiple applications. Okay, how do is there a way I can duplicate this page, Tudor?
No, not right now.
Okay.
What do you want to? Okay, you want to move it somewhere else.
Let's see here.
Just that one. You just need this.
Just use this one.
You just use the large snippet.
Yeah.
And so copy it in. Now open another page because you want to have it clean. Shift enter enter.
Shift enter enter.
Paste.
No.
I would copy that because it was a nice snippet there that you had.
I tried. One sec. Oh,
You tried copying.
Oops. All right.
Okay. So here, the goal here was let's make a tree visible just between headers. So ignoring what everything else is in between, right? So we just to see then of course, if you can add others if you want.
Yep.
So this means that we need to traverse now the tree. The Explorer is more interesting, the Explore view.
Okay.
You can click on the source code or on the tree. You can click on the source code because it's easier to see. And it's in the Explorer view, you have two parts. You have the source code and you have the tree. So you can click on the source code. Yeah, click probably twice.
Oh,
and
okay.
then it gets you to the place
Got
in
it.
the code afterwards. So we need to traverse the tree on the right. And whenever we find a header, the problem is, right, that we need to build a tree, but your tree is not like header, for example, header 2 is not a parent of header 3.
Right,
in
exactly.
the tree on the right?
Yep.
So which means that we need to traverse our scene, right? We need to traverse the absence text tree on the right, but then construct another tree based on the rules that we are interested in.
And is
the
that
simplest?
Sorry, my recollection is you created the adjacency, a list of adjacencies.
Mm-hmm.
And so did you actually do that by you walk the tree, and whenever you get to a header, you're making a you're linking the you omit the header 1 goes to header 2. Root goes to header 1, root goes to header 1, header 1 goes to header 2. Yeah, okay. I'm following. Yep.
So basically you need to build the stack of what's the current header that we have. We're building a stack.
Yep.
And then you're going to connect, you hit a new header, and then you're going to say, is this header deeper than the one we have on the top of the stack?
Right.
If it's deeper, I'm going to add under it. If it's not deeper, I need to pop the things from the stack until I get to a place where I can insert this one.
Right. Yeah. Okay. Hang on.
So we have a traversal that needs to keep track of the stack, and then it needs to keep track of the connections.
Right.
Between the headers. So this is achievable. Easier. The easiest thing to achieve this one is with the visitor.
Yeah, I saw that. Hang on, just Traverse. Visitor. Oops.
And so you can say something like, like you create a visitor.
Yeah.
Yeah, exactly. So you create here, let's create a visitor. We have to give it a name. I gave it the name header visitor, for example.
Sorry, hang on. I'm literally don't know what to type.
Like literally like this. We have to say we need to create a visitor. So create, say, a visitor, okay, V, and then let's call it a header visitor so that it's more qualified. Okay, GK header visitor, right? And then new, right? And now, of course, this doesn't exist. So you need to go and create it. And so we're not going to look to it, but you should subclass le content node visitor.
Yep.
Yeah, that's the package. Great.
Content
Content node visitor, the one. Yeah.
Yep.
And yeah, you say okay.
All right.
Okay, so now we have that visitor. You probably should instantiate it, I guess. But I would just make a single snippet with the entire code. So then we have to say to the visitor, v accept.
So do I put it in this box or the new box?
Yeah, I would put it, I would put it there.
Okay.
Because the visitor will have state, right? It will accumulate, for example, connections. So if you only instantiated once, and then you run multiple times the algorithms, you'll get dirty state because you'll carry the state from it. So I say, okay, accept, and then you're gonna paste the AST there, pass the AST there, right?
Yeah.
And then let's just, and at the end you want to inspect V, but yeah, it should be okay. I don't know what accept is, so I would just put V at the end. Yeah, you see, this one, it gives you.
Yeah. Got it. V. This is what you're saying.
Yeah, exactly. Yeah.
Got it. Roger that.
Right. So then you're in the visit, you see the visitor, right? So now we should go and implement the visitor. You're already there. So of course now accept exists, right? But doesn't do anything.
Right.
So if you go into meta in the visitor.
Go into meta in the visitor. Meta.
Here.
Yep.
Then we need to create a new method. And the method, so it should be, I think it's visit, let's type visit header, is it? H, yeah, header. So great. And first thing you do every time you're using a visitor, you're gonna do a super visit probably, just to make sure that you're not visit header.
Got it, okay.
And then the same, a header. So like this, be sure that, yeah, you need a colon after visit header.
Roger that. Okay.
Right, so let's accept this. Because then this is like when you haven't done anything, right? So if you can run the V again, I'm gonna get the same thing. So next thing we do, so one of the things we could do is we could say, let's just accumulate all the headers.
Yeah, and by the way, so if my first instinct is, I would just prove that the visitor works, and I would just have it print the node I'm in, right, to the inspector or whatever. But that apparently is just not the way you do things in Smalltalk.
No, kind of is. So that's what you would do. So, but not printing. You would want to accumulate that because, like, we like objects. We don't like. We have a disdain for strings.
Right. But I saw somewhere in the tutorials, like, don't print to the console or to the inspector, not to the
ever.
Right. So what is the equivalent of doing that?
So because every view that you have here is like a print string, right? But you can leverage so
Yeah.
much more by just having the original data. So that's pretty much it. So you never want to let loose of the
Got it.
objects that you have.
So the
So
equivalent of doing
here
that. Yeah, sorry. Yeah.
would be a collection of headers.
Right.
So let's do that. Let's go here and say headers, add header, a header, add. So if you, yeah, I would say
Headers.
here headers, yeah.
Yep.
Add. Then yeah, a header.
A header. Yep. Yep.
Yeah, because that's the variable, right? Yeah.
Uh-huh.
Yes. And now, of course, we have to create a slot for it. And ideally, of course, this won't. Let's see if this works. Go and investigate your code.
Sorry, I just want to see if I find my slot. Where did headers go?
Yeah, I think it doesn't refresh properly. So let's investigate this.
All right. So headers is not add was something.
You should run it. You should run that code again. Because now you just modified something. You should run the code.
I'm okay. I'm hitting Command G.
Command G, yeah.
Yeah. So headers is nil.
How do you see that?
Oh, what? No. I saw.
Oh, you got a debugger, right? You got a debugger. Exactly. You got a debugger. Why? Because headers is nil, right? You want to initialize this one with a collection.
Got it. Right.
Do you remember how you initialize a variable?
Yeah. In initialize. Yes.
Yeah, exactly. Initialize. No column.
Right.
And it should be headers, right? So, right. No, okay, but it shouldn't be nil. It should be a collection because you want to add to it.
Right.
So let's make it an ordered collection. Yeah. Yeah. Okay, great. And then the other thing here, always never forget to say super initialize because you just never know what's in the super constructor, basically. So that's a pattern. It's not, you don't have to use it, but
right.
Often one gets shot in the foot because. Right. So now if you go into raw, if you look in raw.
Yeah.
Right. Then you see.
Whoa. Okay. That's great. There. Okay, cool. Okay. All right. That convinces me. That's a lot better than printing.
And then of course, now you can go here and build a view if you want to see that, but yeah,
no, that's cool.
It's kind of your headers. Okay, great.
And
now we need to go and build the connections.
Okay, that lives now in the visitor. So we've already traversed. We've already traversed the thing, and now everything lives in headers. Yes.
Yeah.
Okay. All right.
But now, of course, so this is just the list of things. But now what we want is to build the connections as well. So we can do it in the same traversal.
Is there an easy way to add a text box? I just want to do some literate programming here.
Command Shift Enter. Right?
Command Shift Enter. Got it.
This is how you change, introduce another one of a different, a snippet of a different type.
And how do I make is there a shortcut for create a new Pharo snippet?
Command Shift Enter, and it will get you the
the menu.
The menu to, which is like a spotter, in fact.
Right. Got it. Okay, cool. Thank you. Okay, so we have a list, and we now need to convert it to a tree.
Right, and you're gonna do it in the same visitor.
Yep.
So the same visitor thing, it will remember now headers, and then it will remember connections. So you don't have to add another method. You just have to do here. So in that. Right. So
nice.
But now we need to keep. So what would be the algorithm here? Yeah, so the point here, the point of this exercise is not to find the algorithm, is to find the right or. do we want to spend some time that you find the algorithm, or do we just focus on how do I, once I have the algorithm, what do I do with it? Depending on how much time you have.
Oh, got it. Since you've written it before. Actually, I would like to just convince myself I can write down the algorithm.
Yeah, go ahead then.
So
Then I let you say then.
yeah. I just gotta record what I think. So we currently have. Oh, wait. How do I?
This is an interesting case. Right? You see here how this should be like this.
Yep.
Right? So this is looks like it's the one below before it, but then it's like this, right? And then if I have a root here that goes like this,
Yep.
then I'll have the next one is going to be like this. So we have to find an algorithm for that.
Right. All right. Is there a way that I can pull that right pane? Is this that Eric problem that we talked about? It's like it's now one pane too far to the right.
So exactly. No, let's just see. So
yeah,
why is it? And this is exactly what you're seeing. So every time you find yourself going too much to the right, right? It took us a while to figure that this is a pattern, and it's a pattern.
Yeah.
So why do you go one step to the right? Because you're concatenating generic views. This is a generic view.
Right.
This is a generic view. So what's the solution for that? Well, a custom view here.
Custom, yep.
Because if I would see the headers right here, then I wouldn't have to go investigating them on the right.
Right.
So I can go and build quickly a GT view.
Okay.
Just for the headers.
Yeah. Okay, I forgot the syntax. It's
there's no syntax, but yes.
Yeah, right. It's so this is a GT view headers. And, sheet. How am I doing here?
You're not bad.
And then okay, so now we have to create a block. Do we have to create a block element?
So if you want, you can take it from the Slack.
Yeah, for sure. Please. Oh, close. Thank you.
So so this one, the first one is an annotation, right? Pragma.
Yep.
And then you say a view list, and then titles, headers. That's a string, and then the items. You specify how you want the items, and that's it.
Awesome. Oh, that's cool.
So now you have your headers, right?
Okay, great.
Now, right? It's there. You are. Right?
This is
you
great.
Press your things. Now you're into this.
So we have there's actually there's a root. Shift enter. How do I make a new line without creating a new?
Control enter.
Control enter. So that's like a heading 0. One, and these are actually, they have a heading level in here.
That's an interesting thing. So notice, okay, how would you find this out?
Yeah,
it's interesting, right? You clicked on the one, you see that this is header 2 right now, right?
All right, and there's a number signs.
And those are telling you you're now looking underneath this header 2.
Yep.
So not the most interesting thing, but what I would, because now you want to say, what can I learn from here?
Yeah.
Not what's the position of this one within the context. That's not an interesting thing.
I'm glad we're doing this. Yeah. Okay. So I'm not quite following. I think what you're trying to, I think based on history, I think what you're saying is bring this up here.
No. So let's see. Let's decompose. What do we want to? So you had a very interesting question.
Yeah.
Can I ask a header?
Yep.
For its level?
Yes.
because that would be your expectation, right?
Yes.
Now, the thing that you see on the right, that's just the abstract syntax tree, which is made out of objects. One
Yep.
of the objects is this header node that you just selected. You found it.
Yep.
You don't need to look. Now, because remember this, every time you see something, every view is guaranteed to, or is targeted to work for a specific set of questions.
Yes.
So never ever click on the view in front of you before you know what your question is. You always ask the question,
Yep.
then you choose the interesting view, never the other way around.
Okay.
Because otherwise you let the tool drive you, and that's never a good thing.
Okay, wait. All right.
No,
My question is,
seriously.
yeah. That's
So-
it's interesting, right?
so
So I want to
now-
know what the okay, my question was, somewhere in this node, I know that there's a little there's a number, right, that shows me the level.
Probably, right?
Yeah,
So that's
yeah.
a very nice, it's a very nice thing to think about. So this thing here is probably not the most interesting thing to see, although it actually is, but it's, I don't necessarily, like, this is not where I would look first.
Yeah.
What I would look first would be either here or here at this moment, just to see. Raw always gives you the ground truth, right? Every view is a partial representation of this. You see, so you have this, but even this one, if I look at this one, number signs, and then I have a collection, and this is like, oh, that's so raw. So let's take a look at meta. Is there anything that hits the number sign? Is there any other method that is maybe interesting? Any other one?
Got it. Yeah.
So you see here, right there, it says, right, number signs is already a collection. And here we have something that says header level, which says, give me the size of the collection, which is what we're interested in.
Yeah.
And in this case, only up to 6
Actually, that's
levels.
interesting. Stand by here. So I clicked on here.
Mhm.
So this is an ordered list of headers. And this is actually an ordered list of header nodes. When you do raw, that actually, it doesn't show the collection, it only shows the one thing.
Because
Yeah.
this Explorer thing shows you the context, like within this one, within the whole source code, which is very useful if you're trying to debug some part of the
Interesting.
of the ASD.
Okay, got it.
Okay. So now we found it, right? If we ask header level to our header, then we know what level it is in, right?
Yes. So
Good.
I think what I'd like to do is now put, I'd like to. Okay, so I know, method, is that what you call it? What do you call the function?
Yeah, it's a method. Is a message.
Message. Thank you.
Right, you're sending a message, or it's implemented as a method.
Great. All right. So if it's greater, head level, current, it's greater than current, then push it's a child, so push onto stack. Otherwise, it's Oh, so this is what you're saying. If it's not necessarily peer, you have to pop off the stack until you have
until the condition is met, right?
Right,
Until it's higher than. So
yeah, pop off stack until equals to current. Okay, that's good enough for me.
Then, right, and then you probably, if you probably want to do these ones, like this one, you want to do this one as a first step, and then afterwards you do this step.
Okay.
Because that's the generic case, right? You want to bring the state in a place where the current header is higher than the last one.
Got it.
And then you're gonna add it because you're gonna add it somewhere.
Pop until current is
yeah, the same condition that you had on top here. Current header. You pop until current header level is higher than the last.
Okay. Right, and then
Actually,
that
not
takes
pop until, pop while.
Pop while, sure.
Or, yeah, while this, then.
Stand by. I'm just catching up with you.
Yeah, and then you do the then push onto the stack and create a child. That's the algorithm, right?
Okay, hang on. I'm almost there.
Yeah.
So is there a condition here?
No, and the condition was already met, right? Because you're gonna do it until, and it's gonna be guaranteed if you have a root with level 0.
Right.
It's always gonna be guaranteed that you're gonna hit that.
Okay.
Okay, so there's no other condition afterwards.
Cool. I think it will get clear. It will be absolutely clear when we code it.
Yes.
Okay. Shift, Control, Enter, Pharo. All right. Okay, I am ready. So you're saying implement this in the header. Oops. All right, so we have a stack. Pop.
So you might not know how to do a while loop.
Yeah, right. In fact, watch how good I am at Googling.
Or we can play the human level AI.
Sounds good. While.
So basically, right, like if true, if false was done, like here's a condition, then 2 blocks, right?
Yep.
So obviously the result of the while is going to be a block. But so in this case, so is the condition. So you start with the block, which is a condition.
Yep.
But an if you only do it once, so you don't need a block there.
Yep.
But with a while, you need to say, I want this one repeated many times. So
wait.
Start with the block.
Yeah, got it.
And the stack pop thing is going to be, is part of the, there you are. You found it on Google. Look at that.
Yeah. Right. So let's see here. So the pop value is the stack pop. That's a temporary variable.
Why do you do that?
I'm sorry. I'm just working my way to an expression.
But why put it in a variable?
Oh.
So here, just to read, let's read this one out. Right?
Yep.
So can you read this to what you pasted here out loud?
Hang on. Control.
Command Shift F, but you're missing a dot here.
What did I just? So while a condition is an expression.
So this is the condition.
Yep. So I was
Okay.
yeah.
So
while
what is your
true,
condition?
right? I'm gonna pop off the variable, and I'm just out of convenience. I just put it into a temporary just in case if I need it. Oh, but you're saying I don't even need to save it?
No, you probably don't, I guess.
While true.
But wait, what's first? Is it the condition or is it what's the condition in your algorithm here?
I don't have one yet.
You're right. So, but while true comes after which block? After the condition block or after the computation block? You see here you have one block while true and then another block.
Yes, I don't have the expression yet. The condition. Condition is a header level. While the current header
you
level,
need the condition, right? Right.
Is more than current header levels. Current header level. Self. Header level.
No, there's no self here. Self is a visitor, so you don't know that yet. But you already said I want to have a stack, right?
Yep.
So a stack also has a top.
Yep. Right. So is that okay? Stem. Yeah. Right. Hang on. So this is a header level that I'm visiting, and I need to ask: is it while it's greater than what's on a stack?
Is this how it must feel with the on the whiteboard exercise?
Yeah. right. And recording it.
I see.
Well, the header level. More than. Okay, is it stack top?
And then, yeah.
And why is this red?
Because you're missing a dot here.
I'm missing a dot here.
Or somewhere you're missing a dot.
So I can do this.
Right. And
okay.
Right.
Okay.
But,
okay, got it.
Right, but then you have to delete this one, of course. You have too many while trues. No. What? Not all of it, just this part.
Oh, I hadn't even parsed that yet. Okay, so while that's true.
Yeah. You want to pop the stack.
Nice.
Yeah. Yeah, that's it.
All right.
Okay, and now you still want to do something. So first of all, your stack is probably not initialized, I guess. Which is something you would find out if you would exercise this now.
Right. How come I didn't get a stack nil error?
I think you did, but you must have had it because I can see here.
Oh, sorry. Top was sent to nil. Thank you. Yeah. Okay. Got it.
Right. So I don't see in the recording because you're only sharing one window. I don't see the debugger window, but I suspect that I can.
Okay.
It
got
doesn't
got
matter. It's good. That doesn't matter.
Yeah.
Yeah. So what was the solution there? How did you do that?
What?
Ah, you're using this old GT.
No, I just downloaded it.
No, this is an
No?
old one. No,
Okay.
this is old. Go here.
Go.
You're using it with Alfred, and I suspect that it's getting confused when you have multiple. I noticed it yesterday.
Oh, yeah.
So you see here, this is 1087,
Yeah.
and the current one is 1100. I don't know, something.
Huh. Okay. Is it worth quitting and
Well, yeah, so you're like 70 versions behind.
Okay. All right. I'm going to quit and then I'm going to
But wait,
re-download
no,
this
don't
all.
quit. Then commit first. Commit to Git. Yeah, you have outcome. Yeah, maybe refresh this. Right,
Nice.
changes, commit. Visitor. Okay. Push. Okay. Oh no, you haven't.
No worries.
You haven't solved your SSH add thing, right?
It did. No worries. Hang on. Do you see anything right now? Or just
No. No, I don't see.
Okay.
So you should run this ideally in your setup. Paste
I'm
it
just
in
gonna manually
Slack.
push. Git push. Oops. Okay, it's pushed. Oh, key is not that. It's. Do I push the public key? I'm sorry. Do I SSH add?
Yeah, just run this one in the command line.
Yeah, I don't.
SSH add
My
minus
key is
K.
named.
Yeah, then
okay.
yeah, you have to point it to your key, but that should be the thing to do, and afterwards it should work. Did it work to push from the command line?
It did.
Oh, then you're already there, but this is no longer up to date.
Does pull work? Oh, because it's
Yeah.
public. Okay. All right. Quit and then install the new version.
Yeah. So it was actually one of the sessions with you and Eric that helped us identify the problem with the corrupted methods in the browser. So we fixed that one.
Nice. Okay. Am I using the right version? Here, let me share.
So if you're using 1154, then you're good.
Sorry, trying to find the Glamorous Toolkit. Here we go. Okay, is this the right one? Where did you see the version number?
Here at the bottom. No, it's not the right one. It's 1087, right? At the bottom.
1087. So that's the wrong version?
Yeah, if you go on Glamorous Toolkit on gtoolkit.com, you're going to see there it's 081154.
Okay, I also have 1151. Is that better? Or is it still old?
Yeah, no, that's good enough. It's probably from yesterday or so. So, but you're running, how do you yesterday you were showing the whole desktop and I show you just using Alfred and you were saying
Yeah.
Glamorous Toolkit and
Yeah.
Alfred will give you the last Glamorous Toolkit that you chose
Oh,
for
really?
that query, right? Because it's
Well,
optimizes for that.
I have no
So
idea.
if you have multiple of those directories, then
But I'm actually just get rid of the old one. Okay. Which is what I thought I did. This is so I got to show you this to you. I grabbed, I'm not going crazy. I grabbed the executable from 1151. So this was installed yesterday and it's actually pulling up 1087.
but why did you moved the executable out of it?
Yeah, I did.
Why?
Why? It's just, I just thought it would be better if I had it live in the.
No, but that one runs an image and the image is relative to the place.
Okay. Oh, I've
So-
actually been copying it up to the root. Okay, so I'm gonna run it out of this
Yeah.
one.
Yeah, but run, you have to expand it, right?
Yeah.
Okay. So now run it. Yeah. Yeah, much better.
Dang.
Right?
Okay. All right. Okay. Now
Mhm.
I have to pull.
Meta channel.
All right. Looking good.
Just a second.
Excellent.
Okay, great. Right. We're looking at the wrong, we're looking at the string node. You were looking at the visitor before.
Sorry, hang on. La string node. V is a GK header visitor. Oh, it can't evaluate that.
Because you have top, so now you need to go and browse the class. Right. If you would have taken the latest, the very latest GT, then you would even be able to embed. You can expand the class in place and browse it easier. But up until then, Command B.
Command B.
B.
And what happens if, do we have to push something on the stack?
Yes.
I'm just wondering what will happen if the top is empty?
Well, but how did you say, what did you wrote here in the, you have an item on your list, which kind of addresses this issue.
I do.
Yeah, you do.
The while?
I would just maybe go once more through your list.
This thing.
You
I'm
have
looking
two
at
lists
this.
apparently. Yeah, you have two.
Yeah, take
No,
two.
so
Okay.
you said here you have two lists.
Yeah.
So you have the one up below it. You have saying that the root is header 0.
Yeah.
So where's the root in your code?
Yeah, there is no root.
So one solution here could be to
push something on the stack. How do I make something of 0?
well,
or just say if it's empty.
Yeah, or just say no. I mean those ifs no. But you can just put a synthetic lab header node on the stack.
So I'm assuming it's like push a header.
It was le header node. New.
All right. Awesome.
Let's see if this one works.
Collection is empty self on top. What does this mean? Is that just informational?
No. Yeah, that one means it's information saying that this method is overridden somewhere else in the hierarchy. But you're in the visit header, if you expand that, you're in the stack top. What is stack? Stack is already popped, which means that your condition went over the allowed thing, which means that you're missing something to initialize the header, right? I guess.
Yeah. I'm just trying to catch up with you here. So,
but I'm not sure that you have executed this. This could be their older. I'm not sure you executed this, that you re-executed the code. I think that was an older debugger.
Stack is empty. I popped it. So is my condition wrong? If my header.
You saved stack push in the header node. Can we quickly check the header node? If you look at the header node, header node header level, the header node new header level. So
sorry,
if you go in there, if you browse your node or your header visitor,
look at
in the meta. That's my. If you would, the worry I have here is that you have there's an empty stack, right? And I don't know how did you manage to have an empty stack when you're pushing something onto the stack. So when you're instantiating stack push stack, when you're instantiating just this, something is problematic, right? Now, by the way, right now we are not using any TDD like in the flow, and here it would help to use that. But so before you do anything, I would just look at GK header visitor new. I would just evaluate that one, but I think you've done that.
Yeah.
And
just stand by here. Oops. Raw. Wait. Sorry.
You're looking at the collection now.
How do I look at? I want to find the first header node. Where is the First header
W- But something is, I don't know exactly what are you looking at here. I think you're looking at what was in the, what's in at the state in it from the debugger or something like that. I'm not sure exactly what you're looking at.
Got it. So,
Because
Yep.
right now you have in the headers, you have something
yep.
and you have nothing on the stack. That doesn't make any sense. So let's just evaluate only that one just
Yep.
to see. So now you can see, right? That's exactly what you expect. You expect to have headers empty and a stack with one item on the stack, right?
Yep.
So that's great. Now let's actually take a look. When I have this empty stack, empty header on the, yeah.
Mhm.
If I have the empty header here, the header node new, that's what I added in initialize. If I just inspect that one, what happens? And of course I need to go because this is a stack, so it's a collection. So I need to look at the items. Not the raw. Raw is not so interesting. Yeah. Right. So what's the header level? So if you go to here meta, and then you see header level is a unary method and means that I can have here a little play button.
Oh, yes. Okay.
So that's 0. That's kind of correct, right?
Yep.
That's what we expected. So
Yes.
we've ruled that one out now. So if we go now back to your algorithm to visit header.
Okay. Okay.
So
So
what does
I'll be
it
honest.
say here?
The first time we go through it, the header level is 1, right? That's the.
Yeah.
Header level is 1. 1 is more than 0. Wait, is that right?
Right.
Is that 1 is more than 0, and pop the stack. Do we have those flipped?
This is something problematic here.
Yeah, while false.
Yeah. So let's look now. That's great. So now, because that's exactly what you expect. At the end, you expect to have an empty stack. But of course, now we just need to create the connections.
Yes. Okay. Got it. This is like a coding whiteboard problem.
It is like a coding whiteboard problem.
But this is worthwhile. Actually, okay. So while it's false, pop the stack. And then at the very end, we have to emit we have to add a connection to an ordered list. So it would be in connections, add, and it's something like a from to. All right, so we've executed this expression. Now we add connections. Is it add? Tuple? I'm sorry, what is that? Is it?
You can say an association. An association is just any object understands dash higher than, like arrow. A
Oh, you're
dash
saying
and an higher than. So
like
you can say
a dictionary? Is that what you're saying?
no. So any object understands a message that looks like this. A dash and a higher than. Like this, yeah. Any object understands it. So you need to add, you need to send it to some object. but the object is stack top. And then the from, that's the from, and the to is going to be a header.
So you're saying,
You want to add the from to a tuple to the connections collection, right?
I
And
think
the
so.
tuple will be formed by
Yep.
the stack top.
Oh,
That's the from. And
Yep.
the to is a header.
are you, okay.
Just to say, stack top there. Stack top, right?
Yes.
It's this one here.
Yep. Wow. My keyboard is in a strange state.
What are you typing?
I'm I'm trying typing backspace and it's not. Hang on.
Are you using Dvorak or something?
I don't know. No, in fact, I just switched keyboards because I'm having a lot of problems with my hands. What the heck? Stack top
Mm-hmm.
and a header.
Yeah. Mm-hmm.
Got it. And just to make sure I understand, this in and of itself creates a dictionary entry. Yeah,
It's an association, it's called.
you're right, which is the same as like a dictionary entry.
It's like a one entry in a dictionary.
Yeah, yeah, okay. Excellent.
You
Connections.
need a
and-
dot here.
Yep.
Yeah.
Great. Connections.
The problem right now, this one is interpreted as a method. Yeah. So now.
So connections is in order.
You should probably say it, I guess. And now connections.
No, no, no. Where do I see my slots? Wait, where are my connections?
It doesn't refresh properly.
Okay.
The header doesn't refresh.
Connections.
Yes.
Yep. Can I just say connections clear or connection, or maybe empty set? Like this.
No, it should be the same as an ordered collection because you cannot add one array.
Oh,
It's not, it's a fixed size, right? So
okay.
let's see what happens.
Collection from stack is empty. Oh, stack top.
Stack top. Yes, much better. So now, let's see. How many do you have?
5.
How many would you expect?
Don't know. 1, 2, 3, 4. I expect 4. So there are 4 edges in the graph, and I got 5. Oh no, that's 5. No, I think that's right.
Mm-hmm.
Stand by and just look at connections. Why am I'm expecting to see edges. Oh, root goes to header. Root goes to, that's not right.
Is it correct?
No. This should be, it should be from here to here. So what would be a good way to, I mean, you're right. The way I would do this right now would be like a TDD type, just try it with one,
Yeah.
right? To see if the bindings are right.
Yeah.
But
But basically what you saw there was that it's always the root that doesn't that's on the left.
oh,
right?
yeah, right. Nothing's being pushed.
Uh-huh.
Yeah. So let's see here. So push onto stack. Pop, wow. Pop while, I create the edge. So I create a root, goes to header 1. I have to push it on the stack. Stack push. It's not going the way I thought it would, but I'm glad we took this time. Hey, look at that.
Yeah.
Right on.
Looks good.
This is great. Actually, so you know what? I really, and I'm sorry, I'm taking more time than of your time than I wanted, but
No problem.
right now, I actually feel like my ability to understand what's happening has so far lagged what's actually happening. So could we just take 15 minutes to try to set up some test cases here so that I
Yeah.
can actually gain some confidence that I actually know what I'm doing, or that I'm doing what I think I'm doing?
Yeah.
Yeah. So how do we do that? And by the way, Tudor, I gotta tell you, I appreciate this so much. I mean, I've been stumbling through this and, on so many levels. I thank you for taking the time.
Oh, thanks for your patience. So how would you write the tests here?
You know what I would do is
What would the test look like?
yeah.
Don't worry about where you would put the test.
Yeah.
What would the tests be?
For me right now, tests. Sure. Right now, at this point, I actually want to, I would say, assert that the first edge, connection edge, is to header 1. Oh, 2, 3 is a header 2 to 3. Oh.
Right. So I kind of understood that one. So once we understand how you write one of those, then we can write the other ones, right?
Yep. Sorry, 1, 2, 3, 4. It's header 2 to 4. Yep. Okay.
Okay. So basically here, you can actually go right here, and
Okay.
add an assertion.
Oh.
You can say self-assert.
Oh, nice.
Colon, and you have to put a colon and then a condition. The colon is part of the message.
Let's see here. I'm just I'm going to say the connections at.
Why self?
Oh, actually,
Who has the
now
connections?
that by the way, why self here? What
Why
is
not?
self in this context?
Try. Command G.
Nil?
It's just a nil. Nil is an object. It's not nothing, no value. So which means it's accept messages, of course. Because assert is implemented in object, so you can just use any object as a target for an assert.
Flipping awesome. Okay,
So
got
you
it.
can just as well do say serve. But yeah, connections come from it. But assert here, that's just, red is never good.
Yeah.
So there's a space in between there.
Okay, so connections.
Right. And probably you say, first of all, you'll say how many connections there are, I guess.
Ah, right. And then
say,
so do I need to make a method called connections?
Just say probably.
I'm sorry?
Probably.
Yeah.
Yeah. Right. And then you just want to say this connection is going to be a collection, right? So first of all, let's just do the size of it. Then you can say equal. No, you have to.
Oh.
Here it says integer didn't understand false.
Equality.
Yeah, it's just equal. Yeah. Okay. No, you don't have to execute the whole thing. Yeah. As if you would do a test. So what happens here? What happened here?
My recollection is that the assertion passed, it didn't throw an exception, and so it flowed through to get a V.
And as a consequence, you could get an inspector on the right.
Because of the V.
Exactly, right?
Yeah,
so
right.
You will get an inspector on the right anyway if you do Command G, but whether it's a useful inspector or not, it's just up to you, right? You chose to put the V there.
Right, yep.
Right?
Okay, yep, confirmed.
That what you have wrote here is something we call an example, which is like a test, but that returns also a useful object. That's it. That's what it's a simple thing. That's it. And in this case, this little test here actually depends on something else, right? It depends on AST, which comes from some other place, which is also returns an interesting, useful object.
Oh, say that again. That sounded very important.
Yeah, so this example over here depends on this variable, which is defined here and returned by this example.
Yes.
So here you have a composition of two examples.
Yes.
One example and the second example. And the first example actually acts like a setup for the second one.
Yep.
But there's just this idea of setup and test is just sounded useful at the time, but it's just so limiting because you can only reuse exactly two levels. Doesn't make sense.
Right.
So here you can reuse an arbitrary amount of.
Yes. Yes.
So that's why you get this graph of examples.
Right.
Now let's do some fancy thing if you want.
I am almost there. At why? I'm just
You can say first or second or third up to the 10th.
Right. How comes
I say first
connections? Wait,
and say connect V connections first. Connections at 1 is, you can say V connections first. if you want to do that.
But how come, okay, that worked, but how come this didn't work?
You had the colon too much. You had a
Oh.
colon here before the at, and that doesn't make sense.
Nice. Okay, cool. Got it. Okay. Yes. So you're saying there's a better way to do,
So right now, these are just snippets, but you
Yep.
would want to have them available for, CI running some of the time, regression testing, things like that. So you can now promote this because that sounds like an interesting test already. You can promote this to an example
okay.
because that's
Yes.
exactly the code that the example should hold.
Okay.
And you can do that by basically transforming this. So we can do it manually first,
Yeah.
just to see what, just to say what it means. Just a second. Or we can do it directly from here. So let's give it a shot. See if this one works. So in this, here, this is, now you have a snippet. And this is where it becomes this thing with Lepiter, but let's first do it and then we'll reflect on what we've done. So click here. Then there's an EG button. Then let's create a class there, which will be GK visitor examples. Right, enter. Right, a package is going to be your GK tweet. Control space should work. Is it GK2 tweet by any chance?
Control enter.
Control space, not control enter.
No, I know.
Anyway, so yeah, I don't see anything because your mouse is right there.
Oh yeah, yeah. Weird.
Is it small caps?
No.
The K?
Nope. Okay, yeah, we'll do that later.
You have to put a package there because otherwise you can't create. And we can move it afterwards indeed.
Okay, yep.
No, and then you also have to specify a selector.
Okay, Roger.
So because that's the name of the, yeah.
Oh, what is a selector?
Header, the visitor for, I don't know, the name of your test basically. And it should be small caps, right? The selector means the name of a method.
Okay.
Okay. Enter, yeah. What did you? I don't know.
We'll try again.
That should work.
No worries. No worries.
Okay, let's do it manually first. So actually, let's start from here. So we can take this one, copy this code, and create a class, which is called your visitors examples. Just yeah. To do that, you can say GK, Shift Enter and then coder. And then you can plus. All right.
Okay.
Here you can have visitor examples. Apparently it created it already. I think you probably have it already. Enter. right? You already created this class, so that
Right.
that dialogue there that you create, it's something.
Okay.
So let's shift enter, find it.
Uh,
Visitor. Yeah, that was it. Okay, so and then we can put it now in GK2 tweet. How do we do that? Almost. No. Yeah, go back to, yeah, and expand. So in order to, you want to edit, not navigate. So when you edit, then you have to expand this one, and it transforms itself into a.
Okay.
Yeah, okay, again. So that
Right.
was a refactoring, and right. So now you copied this, and now you can go here and create a new method, and you can call it the AST. No, don't call it setup because there's no such thing. That's the AST, right? And then just paste your code. And in here, you actually don't even, you probably want to define it as a temporary here.
Ooh.
And now I would and return it at the end. Probably you want even to put here an assertion to make sure that this one is a good thing, but just return the AST.
Oh.
And yeah, you're missing the dot. And right now, yeah, save. If you save this one, this is now a plain method. There's nothing special about it, right?
Uh-huh.
So you can go here and add a GT example pragma. So with the angle brackets. And notice how, as you type this one, a new set of buttons appeared here.
Uh-huh.
So you can execute the inspect, run it, and this one turned into green. This one here. Or you can inspect it. Yeah, you can run it and it turns into green, or you can inspect it.
Oh, got it. Yes.
Or you can
Okay.
inspect the result, and then you're getting it there. So now basically an example is nothing like there's no real difference between this and a playground, right? A snippet.
Yes.
That's why you can transform a snippet into an example.
Yep.
The other way around.
Got it.
So that's it. And now you want a second method, which will have the contents of your second snippet. No, so what do we do with that one?
So we need to call AST.
How do we do that? Yeah, that's it, right? So that's it. Now, can you execute this?
No. Nice.
So now you could execute it. But what did it return?
It returned a self.
No, it returned. You always
sorry,
look
it
here
returned
in the
a-
header.
Wait. It returned a G key visitor example. Not a G key header visitor.
Why do you think? Why would there's a coincidence here, right? There's an interesting coincidence between this and this. Why would you think this happens?
Yeah, so okay, so there's an interesting coincidence between this.
Yeah,
and what?
this is an instance of
Yep.
apparently the same class.
Yeah, that's a coincidence.
It's an interesting coincidence, right? So why would this happen?
Why would V? I have no idea, but I guess I'm
Okay,
now curious
so
if what happens if I do this.
try.
Yeah, it's independent of what's being returned. So
Try.
why?
Inspect. You have to inspect.
Oh,
That's you still
yeah,
got the
same
same
thing. Yeah.
AGK.
Okay. Why would that be?
How is it here then?
Yeah, how is it there?
Well, you got to. There's no coincidence.
The only thing I can come up with is there something odd about V? Right?
No, because you did it with you repeated it with one, so there's must not be V related.
Parsed. Oh, maybe it's the name of the method of the
No,
message.
no. It's you're missing a character.
Oh, damn it.
So by default, that's why I said it's an interesting coincidence. By default, any message sent, any method execution will return self if you don't say anything else. So there's no void. There are no void messages. You always get something to inspect.
Got it.
So that's why when you see this kind of coincidences, first thing you say, oh, return this message.
This is awesome. By the way, I went from feeling like I'm not sure if I actually learned anything. Like, no, now I've learned a ton. So I can, these examples will help me inspect
so let's just do
what I built
one more time. So return V here and see what happens here.
Yeah.
And of course, you shouldn't return one anymore because that doesn't. Okay, so now.
That's awesome.
Right. So now, right, your tests become, now you have tests, but it's also documentation.
Love it. Love it.
Right.
So
So
here's what I'd love to do. Okay, this is like what I'm super happy about. So if I feel like if we can actually generate that Mondrian graph, what I will be able to do by the next, like with the next couple of days is I will not only render the headers, I'm going to render the paragraphs and create the size. The size of the node will be based on the word count of the paragraphs. I'm going to color them by the hash. So I feel really good about this.
Okay.
Okay. So now that
we have our visitor, it has connections inside.
Yep.
Right. So there is a page with Mondrian.
Yeah.
If you search Mondrian and limit to pages, then there will be a tutorial there about Mondrian, which you can follow afterwards. So it's right there. No, here, pages.
Oh, dang.
So there's a tutorial here, and you will notice as you go lower that actually here, these tutorials here, what are those? What are they made of?
Examples. Yeah, that's cool. Oh, that's super cool.
Right. And that's why I'm saying that there's no just one thing.
Yeah.
If you're just going to take one of these pieces, you're going to miss the whole of it. And this is how all of these things fit together. But basically what you're going to learn here, this is a bunch of nodes, right? Yeah. And then I say, I'm going to take these nodes and I'm going to connect them with edges here. So let's take a look quickly at how do we create the nodes. We say view Mondrian GT Mondrian new, right? That's easy. Then I'm going to say view nodes and I'm going to say with a collection. So I need to have a collection of nodes. Yep. And notice how here, right, I have nodes with ellipses. And then here I have edges with thicker lines. So
Yep.
essentially here we have, I basically take the same thing that I created here. So those view and nodes,
Oh,
and now I'm going to create edges. And the edges is also going to say a transformation in which I'm going to say connect something to something. And then I'm going to lay it out, and that's the tree. That's it. That's what you need to put a graph on a screen. There's nothing else. And then of course you have these embellishments. I want a thing that looks like this and da, da, da. But that's separate. That's secondary.
so this is what you meant by composition. This is composed on top using this one element of composition.
Yeah, this is one of those, right? So we have nodes and edges, and then you can start composing them, but they can also nest them.
Yep. And how did you get
so
a
here, for
radial
example-
layout that I saw somewhere? You can.
If you look into the subclasses of BL layout, then you will see lots of those kinds of options.
BL layout. Oh, wait a minute. So
last time we talked about the one rendering tree, right?
yep.
The one rendering tree means everything in the scene is going to be rendered exactly using the same forces. So I'm going to have elements, I'm going to have layouts.
That is really bizarre. I thought the radial layout came from Mondrian. No, that comes from BL layout.
So the thing is, it used to be a time when visualizations were, even in a morphic world,
Yeah.
visualizations of data were confined to a canvas,
Yeah.
just like you have in an HTML today.
Yeah.
That's what's different about the GT stack.
Yeah.
We took this idea of one rendering tree and extended it to editors and to the visualizations.
That's cool.
And that's why we can arbitrarily combine things in all sorts of funny ways.
Okay, so I should have been paying more attention to Eric's thing. So where do I find a
But
radial?
I can just quickly, let's go through just the basics first.
Yep.
And you can read about this one afterwards if you want, but
Yep.
what I would suggest, we take your thing and I can guide you through it step by step.
Okay,
You
in
can
the
take
next
your
20
snippet.
minutes, that'd be, by the way, I don't want to take up too much of your time here, but I'm too selfish to.
Selfish is good. So let's go to your playground, right? So I'm
Okay.
there, and let's add another one here.
Yeah. Great. Shift enter. Pharo. All right.
So now you can say here, we're gonna create a M. No, leave it because you already have a V. So now we're gonna focus on this snippet, just on taking that V, your visitor, and
Okay.
oh yes, you have this. Yeah, that bug was fixed. It's yeah. So GT Mondrian new. Right. So the first thing we're gonna do, we want to say, do an enter.
Yep. In fact,
now say M again.
Yep.
M.
Yep. You can hear me clicking the key, right?
I can see, and I see the cursor moving, so it's like pressing space.
Is this not a?
Is this one of those black keyboards with arbitrary keyboards mapped on them?
No. Okay.
Yeah, M. That's good.
Yeah, that's good. By the way, just to save time, let's see if as a class. Oops. Just like nodes with.
So no. First, don't no. Stop.
No.
Please stop. No. So you never. At no point a program is readable or writable top to bottom.
Oh, come on, man. What?
A program is always written inside out, right? So that's why the first and the last things here are important. M is the last thing.
Yeah.
No, delete the layout, please.
Delete the layout.
Yeah, just go with me, please. Okay, great. So now you inspect this.
Yeah.
Right, and then go to the live view.
Yeah.
And it's empty. There's nothing there. So a graph. What is a graph? I need nodes, then edges, and then a layout.
Yep.
So first I'm going to add nodes.
Yep.
But it's now, right? So the M at the end is important.
Right. I gotcha. Yeah.
Okay.
Visitor.
So then I say V and then
connections.
And then right no, this
headers.
the nodes. Headers. You don't have that.
Do I have a headers? I don't have headers.
Give it a shot and write headers.
Yeah.
Oh, look at this beautiful IDE.
Is there a way that I can add it from here, or do I have to close
no,
the debugger?
not yet, not yet. You will soon, but not yet. But in the meantime, you can do it statically, in fact.
Yeah.
You can just return headers, right? Because you already have it as a variable there. Yeah. Right. And now inspect this.
Nice.
Good. That's the first thing, right?
Yep.
Now, and then click on one nodes.
That's wild.
And so now click on another one. Right now here, this is where you see how interesting it is that I have a view where this one highlights itself in the overall context, right? But you see like how these views are operators. And if you learn how to combine them, right, then boom, it's like you have compounding really, really very quickly. That
is, I see what you're saying, what you said almost 2 hours ago. That is freaking awesome.
So let's go add edges now, because now you have the connections are already made. So you're going to say, no, inside out.
No, oh, yeah. Oh, man, that's
So that's an M there. No, M there.
I'll get there. I'll get there.
Yeah. But... Okay, so you say connect. Yeah, connect associations. That's easier here, but yeah. Then you're gonna say just the V connections. Right now, M. Okay, done. Okay, right now try to drag them around a bit.
No.
Ah, yeah, because the layout doesn't allow you to yeah, let's do and now do an M3 layout, right? Layout 3, yeah.
Oh, wait a minute, that's not expected. That is wild.
Yes.
Oh my gosh, I have no idea. Who is that?
So there you go. And who's the other header? Who's the other? So you click on this one.
Oh, we're missing
now
a root node. Oh,
you see what just happened here?
This is so great.
How long would it have taken you to debug this and figure out to put the?
And so there are times when this has been so frustrating, right? Trying to do a whiteboard problem in a language that I barely have a grasp of the syntax after 3 weeks, but this was like such a huge payoff. Oh my gosh, that is and so all the things that you said in the beginning, that is flipping awesome. That is so cool. I get it. That's interesting. So yeah, I'll tell you, hang on. So it's actually my test case is wrong, right? Is that there shouldn't be 5 edges. There should be 7. That's really, there's 5, there's 1, 2, 3, 4,
no,
5 nodes.
How many, but how many edges do you see? How many edges do you see here?
1, 2, 3. Right. Oh, so the assertions, my assertion is, the assertions are correct. I never tested the connections. Right?
You never tested the headers. The headers
that's flipping awesome.
So what Markdown does, and this is another thing here. So when you will look, for example, at things like dot files, right? You will have to have you have to define all the nodes up front, and then you're going to say, I'm going to connect the edges there.
Yeah.
But here, you said, here are all the edges. So obviously I gave more edges. I gave 5 edges, but it only drew 3 of them. Because there's the map. So Mondrian is in fact a transformation engine, which does, it's like an object to graph transformation. It's incidentally also visualizing things, but it's like, you know, ORM does a transformation between tables and objects, and here we're doing it between objects and graphs, and that's it. So, and it does some, you know, you can, it's very easy to just quickly put things together and see if you have some, you know, the things that you have in mind.
I love
So
it.
if you add to that, to your headers, your stack root, stack top, it will show you properly the graph. As you
Okay, I'll
expected.
get there. Awesome. Now I want to see the layout. Okay, how do I oh, that is great.
Right. So yeah, click there. So this is, you're gonna see this one often. This one here is, you have a builder. Now you browse, so Command B on that one at the moment. Command B, right? So you're gonna see this one often. This this pattern that we have. It's a builder. You just get an object that only gives you a language, basically.
Yep. Yep.
And yeah, so.
Okay, I gotta say, this is joyful. Awesome. Okay, so I see a very clear. Okay, I'm gonna write my tests. I'm going to fix the connections. I'm going to parse the I'm going to parse the paragraphs. I'm going to size the nodes. I'm going to color them. And I'm going to generate. I will then write another class to parse a set of Markdown files and then generate frames. They'll then go into FFmpeg to generate a movie. That's
that's the plan. Okay.
Yeah, that's the plan. That is flipping awesome. That was I gotta tell you, that was a little painful. Tough sledding. And it's all excruciatingly recorded, but worth it at the end. That was really flipping great. Thank you. So I guess, and then maybe to answer my own questions, kind of the question always is like, is the juice worth the squeeze? Right? To learn all this new stuff, right? And I think what I was saying in the beginning is like, okay, if all I get is the equivalent of D3 and DataViz or GraphViz, whatever it's called, then the answer is probably no. But this is different. Like you get more than just the visualization. It's that is really great.
So like the thing and that's basically one of the challenges that you know, people come. One of the first questions people ask is that, what exactly is GT?
I was having a conversation with James Shams. Like, this defies easy explanation to me, even, you know, like 2 weeks ago.
Okay, right. So, and the thing is that people expect a very limited category.
Yeah.
Right. So and because that's what we have been somehow trained recently, right? And but it takes a while to understand what this compounding means. And so, for example, there are these little things that make these things. The fact that you have snippets, and then you haven't done it yet, but next time you're going to transform your document here. After you write your examples,
yes,
we can transform it and write a tutorial for other ones to read your code.
Yes.
because that's exactly what we are doing when we
Yes.
are when we like all our documentation is like that, and there's going to be almost zero effort to build the documentation, right? And
Oh, it
like
worked.
you
The
pay
commit
the
worked.
same.
Push worked.
Yes.
Oh wait, no, the push worked. Hang on. Does it? Does it? I think the push worked.
It worked.
It worked.
Right, it worked.
Yeah, Tudor, I think that's gonna be the challenge, right? It was like, and it has to be understandable with less than 10 hours.
Of course.
Yeah.
Of course.
But
I mean,
no. I'm sorry. Somehow people have to understand like what's possible in less than 10 hours. But I mean, I think I'm learning.
but let's put it differently. I was listening to your recent IT Revolutions podcast.
The Ideal Cast.
The Ideal Cast, yeah, sorry. Where you're looking back at the history of DevOps, for example. And so tell me, how many people understood the implications of DevOps 10 years ago?
Or in 2008, right? I think the implication in Patrick Baugh's interview was most people left the room. Just
no, and that's what, but and even then, right? For the people that started then, because you were still giving examples of interesting new things, interesting new implications, all the way to 2017. So it's like a decade, and you're still finding new interesting implications, right? And what does it mean for the enterprise, right? That was an interesting conversation that you were having about, like getting the enterprise mixed with the velocity people and how this didn't mix well. And but that answer, like, what does it mean for the enterprise? That was not obvious, right? Sure. And it took quite a significant amount of time for people to grasp, right? So what did people buy then? They bought something that they could visibly see immediately, which is, of course, kind of, if you look at things here, we actually literally have a decade of playing around with this idea. And it's just that there's no very large community that does that, but that doesn't mean that we haven't exercised it for a long time. And that's why we are seeing lots more of these of connections. And that's why you see all these many pieces that actually start to very interestingly combine with one another. And they're not large pieces, but there are a number of them that are not immediately visible.
Yeah.
And there are all sorts of other interesting implications afterwards. And that's why for me, I was just saying that for me, this exercise with you and Eric is so interesting because I get to see how people react to a message and stay through the pain of even bugs, right? Because those are distracting dramatically. But then what I actually maybe hope to get is, what if you find a way to explain it better than we do?
Yeah. And so, I mean, I guess here's the question I have is, so I'm going to finish this. And I mentioned to you, this is a problem I've been wanting to do for like 10 years. And, I learned, and I've attempted to solve with Vega Lite. And so if I'm going to go forward to do it, this is the closest I've ever gotten to it. Is what I get now? Am I stuck in this weird island of Smalltalk? Like, in other words, and this is a feeling, right? I want to, oh no, like at some point, I want to generate. We need to generate an artifact that you use outside of, and I say this teasingly, lovingly, right? Is
sure. Of course.
And so, what is that artifact? Is it just the image? Is it a JSON file? Is it like at some point, right? I want to create something that I want to share with others, and sometimes it will just be the camera ready image or the diagram, and maybe I can achieve everything I need to inside of GT, or maybe there's things that I want to now take in closure, right, and reach into GT, or don't know yet, but that's what I'll be. I'm just gonna put in a box, revisit at the end of the exercise.
Good, great.
Cool. Well, hey, thanks for taking this on short notice. And this is really exciting to me. So cool. Well, I will be posting updates in Slack.
Great.
All
Looking
right.
forward to that.
Hey, have a great evening. I'm just gonna turn off the recording.